Because of the rapidly changing technology, ambiguity in ventilator terminology has occurred all over the place. Different ventilator manufacturers offer similar or identical models with different names, and the same terms have different meanings on different ventilators. So a guy by the name of Kapadia designed or coined the TLC classification system, which allows all aspects of ventilator terminology to be expressed in such a way that it can be understood by all. TLC stands for trigger, limit, and cycle. There are only two options to trigger a breath. Either the machine does it if the patient does not initiate a breath, or the patient themselves initiates the breath. With that being said, trigger is the signal that starts each breath. It opens the inspiratory valve, allowing air to flow into the patient. If the patient does not initiate a breath, the machine will trigger a breath based on time. This is what we call time triggered or machine triggered. So for example, if the respiratory rate is set at 12 breaths per minute and the patient does not initiate a breath, the ventilator will deliver a breath every 5 seconds. If the patient does make an inspiratory effort and the ventilator senses it, then the ventilator will deliver a breath. This is what we call patient-triggered breaths. The patient-triggered breaths can occur by the ventilator sensing an inspiratory flow or by sensing a negative inspiratory pressure mounted by the patient. This flow or pressure trigger is generally set by the respiratory therapist and is termed trigger sensitivity. If you look at the following waveform examples, a flow or pressure trigger can be detected by noticing deflections at the beginning of these waveforms, respectively, compared to the machine-triggered waveforms, where no deflections are detected at all. As soon as the inspiratory valve has been triggered to open, gas from the compressor will rush into the patient's lungs. The term limit refers to the factor that limits the rate at which gas flows into the lungs. For example, the ventilator can deliver gas at a fixed flow rate and pattern, or at a fixed pressure pattern during inspiration. During the flow limited pattern, a flow rate of 60 liters per minute has been set by the clinician, which is kept there throughout inspiration, as denoted by the straight line across, until cycling, which is breath termination, occurs. Naturally, as the flow of gas is entering the lungs, the pressure and volume in the lungs is also increasing. However, notice that the airway pressure will rise to whatever level is required to deliver the selected flow. So, the longer the flow continues for, the higher the airway pressure and volume inside the lungs will be, which of course increases the likelihood of barotrauma to occur. Limiting the inspiratory time might help with this, and will be discussed at a later time. The flow limiting pattern has also been described as a square or constant waveform. In a pressure-limited breathing pattern, the pressure is not allowed to go above a certain limit. The amount of tidal volume the patient receives is influenced by the compliance and the resistance of the pulmonary system, and thus, the tidal volumes cannot be guaranteed. Saying it another way, if your compliance goes down, then you won't be able to fill your lungs with as much tidal volumes as compared to if your compliance was higher. You will notice on the pressure-limited flow waveform, the flow shoots up and then starts to drop in a ramp-like decelerating fashion. This guarantees that unsafe levels of airway pressures never occur, and that the delivered gas spreads slowly, especially in heterogeneously injured lungs. Choosing pressure-limited ventilation thus prioritizes safety over efficacy. In comparison, volume-limited ventilation will guarantee a certain tidal volume at the expense of high pressure levels, whereas pressure-limited ventilation, although the tidal volume is not guaranteed, the airway pressures can be controlled. Let's review for a second. Trigger is the start of the breath. and can be either machine or patient triggered. The gas flow is limited by either a certain amount of flow or pressure. At some point, inspiration must come to a stop and expiration starts. This is called cycling. Cycling is the signal that stops inspiration and opens the expiratory valve to start expiration. The circles denote where expiration begins. Notice the flow curves in both the flow-limited and pressure-limited waveforms. In the flow-limited waveform, the flow is constant until a certain point where expiration begins, and then it drops down and past the baseline. In the pressure-limited waveform, the flow initially shoots up and then gradually comes down in a ramp-like decelerating fashion. Let's go back to the flow-limited waveform. As the flow is constant, gas continues to enter the lungs, causing the pressure and the volume inside the lungs to increase, while in the pressure-limited waveform, the flow initially shoots up, causing the pressure to hit a certain limit, and then keeps it there until cycling occurs. As the lung compliance changes, the amount of gas that can enter the lungs also changes, which is why the lung volumes are different in pressure-limited ventilation. Common signals for cycling are volume, pressure, time, and flow. It is important to note that the pressure-cycled ventilators are rarely used, though pressure cycling often acts as a backup form of cycling when the airway pressure reaches the set high-pressure alarm level. In volume-cycled mode, once the prefixed tidal volume is delivered, for example, 500 milliliters, the inspiratory valve will close and expiration will occur. In time-cycled mode, the inspiratory valve will close and the expiratory valve will open after a fixed inspiratory time, which is set directly or indirectly by adjusting the respiratory frequency and IE ratio. In a flow-cycled mode, the ventilator can sense a decrease of inspiratory flow and shut the inspiratory valve when it has decreased to a certain level or a fixed percentage of the peak inspiratory flow. If a pressure-cycled ventilator is used, then the inspiration will stop as soon as the prescribed pressure limit is set.